Last class I discussed about how to transfer the secondary impedance Z2 uh, to the primary. That is, when we are multiplying the Z2 into N1 by N2 whole square, it transfer to the primary side. Similarly, when if we are taking the primary side impedance Z1 and if it is transferred to the secondary, that time we multiply Z1 with N2 by N1 a whole square. This is the exact equivalent circuit of a single phase ideal transformer. Here V1 is the source voltage, RC XM is the core component resistance and the reactance in this IC and XM flow. IC and XM flow, okay, and this is the secondary side induced EMF. Secondary side current is the I2 and R2, and X2 is the secondary side winding resistance and leakage reactance. Okay, so this secondary side resistance, reactance and current as well as the voltage induced EMF quantity can transfer to the primary. Again we say this the value can transfer to the secondary. Suppose the secondary winding resistive drop I2 into R2. When it is transferred to the primary, just multiply I2 R2 into N1 by N2. As you know that the I2 N2 equal to I1 N1, that is the primary MMF equal to the secondary MMF. From this equation, the value of I2 is nothing but I1 into N1 by N2. Now putting this value in this equation, that is N1 by N2 into I1 into R2 into N1 by N2. So the equation I1 R2 N1 by N2 whole square. Now the resistance of secondary winding R2 can transfer to the secondary can transfer to the primary if we multiply the R2 with N1 by N2 whole square. So the referred resistance R2 dash, that is referred to primary, R2 into N1 by N2. So the total resistance at now, that is written as RE1, that is R1 plus R2 dash. So R1 plus R2 into N1 by N2 whole square. So this is the total resistance when we refer to the primary. Now similarly, the leakage reactance of secondary can be transferred to the primary if we multiply X2 into N1 by N2 whole square. So the total leakage reactance at now Xe1 is X1 plus X2 dash. Okay. Now if I draw the equivalent circuit of single phase transformer referred to the primary, look at the picture first. This one is the primary side winding resistance, X1 is the primary side leakage reactance. At now I1 current flow, that is the primary current, and primary current have two component, that is IE and I1 dash. Again the IE have two component, that is IC and IM. Okay, and IC flow through the RC, IM flow through the XM. Okay, now as we know, the I1 dash, that is the compensating current, actually it is equal to the I2 into N2. So this can be written as, from this equation, this can be written as I2 into N2 by N1. Okay, when we are transforming the current, the multiplying ratio actually just opposite. Remember that. Okay. Similarly, the when induced EMF E2 transferred to the primary, it is multiplied with N1 by N2. When terminal voltage V2 transferred to the primary, V2 is multiplied by N1 by N2. Very simple. So this picture actually show the single phase equivalent circuit referred to the primary. Now when this equivalent circuit referred to the secondary, all the primary quantity now transfer to the secondary. Okay, similarly at that time we are multiplying the N2 by N1 square into resistance or into reactance So here look at the picture very carefully. Here this one is the primary side resistance, that is R1. If we transfer to the secondary side, that should be multiply R1 into N2 by N1 a whole square. Similarly, when x1 transferred to the secondary side, x1 must be multiplied with N2 by N1 a whole square. Okay, now this is the core resistance, this is the core reactance, this must be transferred. Okay, similarly the and now current is flow. Look at the current is flow. Now you are multiplying the current just the opposite ratio N1 by N2. Remember that. Okay, similarly this is your E2. Okay, we are transferring the source voltage V1, that should be multiplied V1 into N2 by N1. So this picture actually the single phase equivalent circuit diagram referred to the secondary. Now when the equivalent circuit in general form, first we have to draw the phasor diagram. Here I am taken as a reference. First you have to draw the secondary side voltage and secondary side current. That voltage, suppose that current suppose lack the secondary voltage at an angle theta 2. Okay, we are actually working in inductive load, suppose. Now the exciting component current have two component. One is the magnetizing component current IM and another is the core component current IC, that should be in phase with the V1 dash, that is actually equal to the E2. Now the I2 and exciting current, phasor sum of I2 and exciting current gives the total primary current I1. Now phasor sum of V2 plus I2 R2 plus J I2 X2 gives the E2. Okay, again the phasor sum of E2 plus I1 R1 plus J I1 X1 gives the total source voltage V1. Okay. Now this is the simplified form or general form of equivalent circuit of a single phase transformer. Here the source voltage applied. Okay, this is the primary winding resistance, primary winding reactance. Here I1 current is flow. Okay, and this is X2 R2. Okay, and E2 is the secondary side induced EMF, and this is the V2. Okay, that is the roadside voltage. So this is the actually the general form of equivalent circuit of a single phase transformer. So student, today I discuss about the equivalent circuit of a single phase transformer. We are referring from primary, again we are referring from it is secondary. So if you have any problem or query, please contact me. Thank you.